Hello class and welcome to your new material in building materials and testing. We've finished the concrete section for now. We're now going to talk about masonry. Now masonry is not actually a material. This is actually a methodology. And you see this all over the place. You see this when you ever see a wall being built on a house in Herbal. What are they doing? Are they basically pouring concrete into the wall and making a really big solid concrete wall? No, they're not. What they're doing is they're getting small concrete blocks and they're arranging them into what is a block wall, what is called a masonry wall. They're placing the blocks on top of one another, just like Lego, if you've ever played with Lego, and they're sticking the blocks together with mortar, a type of concrete, and they can make walls, they can make columns, they can make curbs, all sorts of things using this technique called masonry. Masonry is basically a term which means small objects being put together to make large objects. So it's basically what we would call block work or brickwork. That's what masonry is. So it's not actually a material, it's a methodology. The reason I say that is these blocks, these masonry blocks, could be made out of several different materials. They could be made out of stone, they could be made out of concrete, or they could be made out of clay oven bricks. We'll talk about those different materials later. But first off, I want to talk about masonry. So it's a term that is used a lot in the construction and building industry, where basically small units or blocks are basically stuck together with mortar. Now mortar, as you've learned, is a very stiff and very low slump concrete. And these blocks can be made out of several materials. They can be made out of stone, precast concrete blocks. That means that the concrete was set and hardened off-site and then brought to the site. Or they could be made out of clay oven bricks. So just remember that when we use the term brick, we don't mean blocks generally. We use the term brick solely for clay oven bricks, where the clay has been heated and hardened and made strong. So what we're going to be doing here is we're going to talk briefly about masonry generally, and then we're going to talk about the different materials, stone masonry, brick masonry, and we're also going to talk a little bit about some of the key aspects of masonry, such as cavity walls. We're not going to do that last line, lintels and arches. I'm trying to cut down the material, considering this is only a 10-week semester. If you're wondering what a lintel is, it's basically the beam that goes above a doorway or windowway. So yeah, that's what a lintel is, and usually in Kurdistan that's made out of a precast concrete. So I don't think we need to cover that anymore. So before we talk about masonry, we need to actually get used to certain terminology. There's some vocabulary that I'm going to be using here. But if you were to look at a block wall, a masonry wall, you would notice that all of the blocks are arranged in a horizontal row. Now that horizontal row is called a stretcher. Now the stretcher is basically the long length of a block. So I don't know if you've ever looked at a concrete block, but basically the dimensions are probably about 150 millimeters depth by 150 millimeters height and 300 millimeters in length. The longest length of the masonry unit is called the stretcher. That is the longest length. Now, when you arrange all of the blocks in a horizontal line, that is called a course. So if you were going to build a wall that is 3 heights of a block high, and they're arranged in 3 horizontal lines, that is a 3-course high wall. So when you are actually putting the stumpy ends of the blocks, the short ends, next to each other, and so the stretcher length is the one that is facing you, then that is called a stretcher course. So you've got 3 terms you've learned here. Stretcher, referring to the longest length of the masonry block. A course, that is a horizontal line of blocks in a masonry wall. And when it's the long length, the stretcher length that is facing you, that is called a stretcher course or stretching course. So you can see a picture of that down below. Now, we've talked about the block having the long length being the stretcher length. Now, the short depth, which is often only 4.5 inches or 150 millimeters usually, that's called the header. Now, what would happen if we were going to rearrange our bricks so that the long length is going into the wall and we're just looking at the end of the block, and we arrange it in a course? Well, all we're going to see is the small face of the block, and that's called the header. So when we make a course where we only see the headers, we call that a header course. Are you with me so far? So remember, the course is the horizontal length of blocks or bricks, how they're arranged. That's called a course. Now, how the bricks are actually, or blocks are put together, that's called a bond. So there's a few different kinds of bonds. So one way you could do it is actually have the long face of the block, all of the blocks having their long faces facing outside the wall. That would be called a stretcher bond. Or you could have the small faces of the block facing on the outside. That would be called a header bond, because either the stretcher or the header is what you see. If that's not completely clear to you at this stage, don't worry. There's a few more slides, but the bond is basically referring to how the blocks are put together, how they are arranged. And then the final bit of terminology on this page is a brick bat. So a bat is not a small flying rodent that sometimes comes out at night. It's also not a big club that you hit balls with. When we're talking about bats in masonry, these are basically blocks which have been broken, and they just have small pieces of the block, and they're usually broken in half, and that would be called a half bat. But why do we do this? Well, it's so we have a straight line at the end of our masonry wall. That will become clear later. I'll show that to you in other slides. So another term that we would use is something called a frog. Again, this is not a dufter. A frog is actually an indentation in the masonry block. So there's different kinds of frogs you could have in a masonry block, but basically they're a way of reducing the overall weight of the block, while without affecting the actual face or size of the block. So remember, the reason why we do masonry is it's much easier to handle. It's one man can pick up one block and begin to make the wall piece by piece. Whereas if you have an entire concrete wall, that's very heavy and you're going to need special machinery to lift up that wall and put it in place. So the smaller the block, the easier it is to pick up, but also the smaller the block, the more blocks you have to put together in order to make a wall of a certain size. And so having frogs or having hollow blocks, this is a way to reduce the weight so one man can still handle it while not affecting the actual volume or surface area of the block. So you don't have to increase the number of blocks you're having to put together. So that's why we have frogs. So just a quick recap of the terminology. For the block itself, the long face, that's called the stretcher face. The short face is called the header face. And if you have an indentation that's placed in the block, we call that a frog. So now we're going to be looking at certain materials which are used in masonry. And the first one we're going to be looking at is stone masonry. This is where we have whole rocks which are arranged together as masonry blocks. They're made from rocks which you would get from the quarry. And as we talk about this first material, I'm also going to introduce you to certain types of bonds. Remember, bonds is how we put the blocks together. So, with stone masonry, the first kind of stone masonry is where the masonry blocks have not been cut. They're not even shaped into cuboids. They're just rough rocks which have been selected and then put together with mortar. And this is completely variable. Every single block or rock or stone is different from the other one. And so this will mean that the courses you make will be wavy. They won't be one steady, flat, horizontal course. They will be all over the show. Now, the great advantage of doing rubble masonry is all you have to do is pick up stones and gather them. So there's no making of the material or preparing the material. And so this is one of the oldest kinds of masonry, if not the oldest. Now, one thing you do need to remember with rubble masonry is because all of the shapes are different with the stones, you're basically going to have bigger gaps between the blocks. This means you're going to have to use more mortar. Now, remember, the strength of your masonry wall is determined by the mortar in a way, because the mortar is weaker than the masonry block. And so if you have a 20 megapascal strength mortar and a 40 megapascal block, well, the masonry wall you're going to be making will have a 20 megapascal strength effectively, because the weaker of the two materials determines the strength. Now, the other thing to remember with rubble masonry is that it takes a lot of labor, because basically all of the blocks are not perfectly aligned, and so it takes a lot more time to build a wall. So here's some examples of some rubble masonry, and as I said, this is quite an old form of masonry. It was done in Kurdistan a long time ago. I believe Salahuddin's castle, which is up towards Perimam, that has rubble masonry. If you go there, you can see all of the rocks are random, and they've been placed as a wall together, in a wall together, and it does take quite a lot of mortar to stick them all together. You can see maybe in that picture with in the top right, there's actually some fairly large gaps between the stone rubble there, and so it takes a lot of mortar, and so that means there's a lot of labor involved as well. Now, yeah, we don't make things out of rubble masonry that often now. It's quite a traditional material, but a lot of the older buildings in Europe, for example, have rubble masonry. And for many of you who have travelled to Europe, you're probably familiar with some of the old stone churches or castles that are found throughout Europe. Usually they're made from rubble masonry. So one of the great things about rubble masonry is that it's easily available. Remember, compatibility and availability is are the two factors which go into deciding a material for a civil engineering application. And the masonry work that goes into making a rubble masonry wall, it's quite laborious because all of the blocks are random, and so when you are arranging a course, a horizontal length of rubble, a horizontal length of masonry blocks, that's going to be wavy and jagged. And then you place a layer of mortar on top of that, and then you place another course, which again will be kind of jagged. And so you've got to sometimes pick up a rock and think, actually, that stone doesn't quite fit with this hole, and then you've got to pick up another one. And that takes an awful lot of time. It really does. And so it takes a lot more time to build a rubble masonry wall than what we're going to learn is an ashlar masonry wall, where basically the blocks have been cut into equal and common shapes. Now, one thing you will notice here with this slide is that it's mentioning that rubble masonry is the cheapest form of masonry. And in a way it is. In terms of the material, it's cheaper. It's cheaper to buy stone rubble than to buy stone cut rock that is cut into cuboids, into ashlar, equal and steady shapes. But the issue is it takes a lot more labor. Now, I have a question for you. When you're building a house, what's the expensive part? Is it the materials, or is it the labor to build the house? Well, back in the day, it used to be the material. It cost a lot of money to gather ashlar bricks and blocks, but it was very cheap to gather rubble from close by in the village. And labor was very cheap because it was the medieval era, and there was a peasantry, and so you didn't have to pay a lot of money to have labor. That's changing now. If you go to the first world, if you go to a country like the USA or Canada or Britain, you will find that the cheapest labor will probably be around $30 an hour for anyone who has any sort of experience at building. That's what you need to pay for labor. Of course, the worker doesn't get all that money. A lot of it goes to tax and it goes to insurances and other things and overheads. But labor is quite expensive now. And so rubble masonry has basically died of death. This doesn't happen now because it used to be the cheapest form of masonry, but it isn't now. It's actually quite expensive because labor is expensive. They are still occasionally building some places out of rubble masonry, but but you're paying an absolute premium for it. If any of you want to build a house in Herbal in the future out of rubble masonry, you're going to have to be paying tens of thousands of dollars more, I would suspect, than if you were building a house the regular way using a concrete block masonry. So how do we arrange the rubble masonry? Well, I don't know if you can see there, but one of the key things is we try to collect the rocks which are most square and most regular, and we put them on the ends, and then we slowly build courses in horizontal lines out from them. And so the real irregular shaped rubble, we put that in the middle to fill in the gaps. And that's how you would go about building a rubble masonry wall. And I think you can just look at that wall and you can see, boy, that's actually going to take quite a long time to build. There's a lot of labour involved in building that wall. So basically, I would say around 1,000 years ago, in Europe, and earlier than that, in the case of the Romans, ashlar masonry actually became more common. So ashlar masonry is the opposite of rubble masonry. Rubble masonry is where you get a rock, and regardless of what the shape is, you use that in your masonry wall. Ashlar masonry is where you cut the stone and you cut it into a shape that is regular. That's what's called ashlar masonry. And so this is where we get these cuboid shapes for masonry blocks. It stems from this theory of ashlar masonry. And you can have two different kinds of ashlar masonry. You can have fine ashlar masonry. So with fine ashlar masonry, you're cutting the stone in 3 dimensions so that it has equal depth, equal height, and equal length. And so you can see there that that's ashlar masonry, and both of those walls have actually been made with stretcher courses. That's called a stretcher bond. We'll get to that later. Now, obviously, it's a lot more costly as a material than rubble masonry, because you actually have to pay someone to cut those rocks. And cutting rocks is a very hard and expensive process. Rock is not the easiest thing to cut, so you're going to need some very high-powered machinery to cut the rock. So the material will be more expensive, but it's also going to mean you're going to have cheaper labour. I would much rather build a wall if I was the labourer using ashlar masonry than rubble masonry, because effectively all of the courses, every time I lay a course, I will have a nice flat surface where I can place the mortar, and then I can put the new course on top of the mortar. It's a lot easier. Now, rough ashlar masonry is basically a compromise between rubble masonry and fine ashlar masonry. So in this case, we're not cutting the rock in 3 dimensions, we're cutting it in only 1 dimension. So this will mean that the masonry blocks will be smooth and flat in 1 dimension, but it will be rough and irregular in the other dimension. It will just face the natural shape. It will just basically have the natural lines of the stone that you picked up. Now, this means that it does take a little bit more labour, but it's still pretty easy to make. because effectively the hardest part of masonry work in the labour is actually having a nice flat course to work with. You're going to have larger gaps next to each block, but that's not actually as hard and difficult as actually building a nice flat course. And so it's got some of the advantages of rubble masonry and some of the advantages of fine ashlar masonry. What a lot of people will also say is that rough ashlar masonry gives the building a slightly more earthy and slightly traditional and heritage look. And so that, I'll have to say, with stone masonry, if you're building a house out of stone, usually you're doing that out of an aesthetic reason. You like the look of stone because there's cheaper and stronger materials these days, and so potentially you're going to choose between fine ashlar, rough ashlar, or rubble masonry depending on the availability and the look you want to give. Now, with rough ashlar masonry, it does give the house a slightly more earthy and traditional look than if you actually had all of the blocks all of the dimensions of the blocks cookie cutter into exactly the same dimension. So it's actually quite popular in fairly wealthy suburbs in Europe, for example, to build stone houses using this rough ashlar masonry. So that's stone masonry. We're now going to talk about brick masonry. So what is a brick? Well, often brick is used as a term, brick is used as a term to describe blocks generally in masonry. But that's not the definition that I use for brick, or you will find in the civil engineering industry. Brick is basically referring to masonry blocks which are made from a material which is clay, which has been placed, and then it's been cut, and then it's been heated to a very hot temperature, and in the heating of the clay it actually goes very hard and very strong. It's clay oven bricks. That's what a brick is. It's clay that has been put in an oven, and this is used regularly for masonry walls. You'll see this around the place here in Kurdistan. Often slightly wealthier people will use brick masonry as opposed to concrete block masonry for their houses or developments, and we'll talk about why that is later. It's actually a bit more expensive than concrete blocks, probably about 3-4 times the price, but it does have certain properties which make it much better performing. So let's talk a little bit about brick masonry now. So remember, brick masonry is where the block is made out of clay, and so you are able to shape the clay into whatever shape you want. And this is great because it means we can get a really standard shape of block. So in this block that you can see in this example, we can see that the stretcher length is 215 millimeters, and the header length is 102.5 millimeters, and the height is 65 millimeters. So you can get very standard shapes like this. Now, one thing you will notice is that even though dimensions may vary from block to block, generally the overall shape, especially in terms of the ratio between the header length and the stretcher length, is always the same, just about. Do you notice that the header length is not quite half the length of the stretcher length. The half of the stretcher length would be 107.5 millimeters. So the header length is actually 5 millimeters less than the stretcher length. We'll talk more about why they always make masonry blocks that shape later, but we'll get there. But that's an example of what a brick masonry block might look like. And you can also see in this example we actually have an indentation which we call a frog, a way to reduce the mass of the brick without changing the overall surface area. Now, let's look at how we arrange the bricks here. You can see that these bricks, if you look at the course there in the top, you don't have a stretcher course and you don't have a header course. What you have is actually a stretcher next to a header, which will be next to a stretcher next to a header. Now, we'll get to that later when we get to bonds. So far you've only come across two different kinds of bonds, the stretcher bond and the header bond. But you can see what is the actual sizes of the dimensions there. You can see that they are actually, that for the top one, it's the work size is what? It's 215 millimeters, and then the depth is 102.5 millimeters. However, in terms of coordination for working out how many blocks you need for a 3 square meter wall, you need to allow for the gap for mortar to go between the blocks. Now normally that gap will be maybe 10 millimeters, and therefore the coordinating size of the stretcher dimension goes up by 10 millimeters. So it's actually the coordinating size, the stretcher length is 225 millimeters. This is not looking at the length of one individual block. It's working out what sort of length does a block take up in a masonry wall. And for the header, that goes from being 102.5 millimeters to 112.5 millimeters. So once we allow for a joint, a mortar joint of 10 millimeters between each block, now you can see that the header length is actually half of the stretcher length. And that helps us arrange our blocks in different ways and different bonds. So even though the actual length of is 215 millimeters, in terms of design and setting out a masonry wall and determining how many blocks we need in a masonry wall, the coordinating size is 225 millimeters. I now want to talk to you about bonds. So we've looked at different materials. We've looked at stone masonry and we've looked at brick masonry or clay oven masonry. We're now going to talk about how would we put those blocks together. So a bond is basically a pattern of how the blocks are arranged. So a stretcher bond is probably the most common kind of masonry wall. It's used a lot, where basically the stretcher, the long length of the brick, is facing outwards. And so you've probably seen masonry block walls all over Kurdistan that look like that. That's called a stretcher bond. Now, one thing you will notice is on the ends of those walls, do you see that with every second course, you have to place half a brick? That's called a bat. You basically have to break a brick or a block in half, and that fills in the gap. That's called a half bat. Now, the reason you do that is because you need to arrange all of the courses staggered so that the mortar doesn't form a long straight line through the wall. It's sort of a zigzag. If you follow one of those white lines from the top of the wall to the bottom, you have to follow a zigzag pattern. And that basically gives the wall strength. If you just had blocks perfectly on top of one another, then it's going to be a considerably weaker wall, because the crack that would need to form in the wall would be a much shorter distance, and so far less energy will need to be exerted on the wall to break it. So that's called a stretcher bond, or a stretching bond is another term. I don't care if you use the subject or the verbing noun form, stretching or stretcher bond. They are exactly the same. The other way we can arrange a wall is by doing something called a header bond or heading bond. And in this example, basically what we're doing is we're having to take the bricks, and we're putting the header facing outwards. And so first off, this gives you a thicker wall, doesn't it? So if you wanted a thick wall, that potentially you could build it using a heading bond, or alternatively you could do a stretcher bond but just have it 2 blocks thick. Now here you can see that again there's actually half bricks or 3/4 bricks on the end of the wall, but these are bricks which have been cut in a different direction. They've been cut longitudinally, and so you only get 3/4 of the block. And by doing this, you get a bond which is quite a bit stronger. It's actually slightly stronger than the stretcher bond, believe it or not. But the real advantage with a header bond is because you have more length going into the wall, you can actually narrow it down a little bit. You could actually have the gap between the blocks, it's sort of wedge shaped, and so this is good for building curved walls, which is something you would use for cornices or wells. It's quite common to see brick walls built using a heading bond in certain places, but also for places where you want to have a thicker wall because you need more strength, but you don't want to go to the effort of building it in a stretcher bond which is 2 blocks thick, then you might use a header bond too. So things such as foundations or columns, they often use header bonds for that as well. So 2 bonds so far, the stretcher bond and the header bond. And both of these bonds require brick bats. Now, the other bond you could use is something called an English bond. Now, this is quite common. It became a very common way of doing brickwork in England around 2 centuries ago, following the Industrial Revolution in England, and so it's called an English bond. But look at the wall there. You can see that you have a stretcher course, and then on top of that you have a header course, and then on top of that you have a stretcher course followed by another header course. Now this is actually the strongest kinds of bonds. If you needed to build a very strong masonry wall, this is the way to do it. And so there's a lot of advantages with English bonds, and I can't quite understand why this isn't done in Kurdistan a little bit more. I think it's just habit. People don't do this. They've never done it, so why would they? But it gives it a lot more strength, and so potentially when we had the earthquake in 2017 and lots of people lost their homes in eastern KRG and in the Kurdish part of Iran, potentially if they had built their walls, their masonry walls, using an English bond, that might have been enough to actually have saved the house, which is a real shame because 500 people died in Iran. This might have saved them, who knows? So there are a couple of disadvantages with the English bond though. One of them is that you don't have the option. You have to make sure that the depth of the wall is actually one stretcher length. So it's going to be a fairly thick wall, which may or may not be what you want. Potentially if you're building a small villa like the villas here in Erbil, you may not want to have a very thick wall because that's actually going to make the room of the house smaller, for example. Now, the other real difficulty with English bonds is, I don't know if you can see this very clearly in the drawing, but basically when you get to a corner, you can't really use bats. You can't use broken bits of brick because they will need to be broken in two different directions, and the moment you do that, especially with a clay brick, it will basically shatter to rubble. And so basically you need to actually have what's called a closer, which is a broken piece of brick, one inside, and so this is called a queen closer. And so you don't leave the exposed broken brick on the edge, otherwise it's just going to fall out. And so that takes a little bit more labor because you're having to actually go around breaking the blocks into the shapes you need. And so it can be a little bit laborious building an English bond masonry wall. It can actually add quite a lot of labor and cost. So just remember that with an English bond you have different courses, which are stretcher courses or header courses, and they alternate. Stretcher course, header course, stretcher course, header course. It's the strongest of all bonds. It does give a little bit of a rough appearance. Some people, there is sort of a belief it doesn't look that attractive, but that's beauty is in the eye of the beholder. Even my wife thinks I'm good looking, so that's just an aesthetics thing. But one of the things, the reason why it's so strong is that you don't have any vertical joints. If you were going to draw your finger down following that white line, following the mortar between stretcher and header, that's actually going to be quite a long line, and it's also going to vary and wave in and out of the thickness of the wall. So it's going to create a very strong bond where a lot of energy needs to be exerted to cause those joints to crack because they're very long. Now, because you can't just use brickbats at the end of the wall, and they've got to sort of be incorporated inside the wall as queen closers, it takes a lot more labor. You don't need to understand that fully, guys, but you've got to understand that it takes more labor to build an English bond, and so it can be slower to build, and more costly. Now, basically, what is a balance between, say, a header bond and an English bond, which is sort of in the middle, is something called a Flemish bond. So Fleming is actually it's the place it's northern Belgium, I believe. So Belgium is a bit of a funny country in that in Belgium they speak two languages. Those in the south of Belgium speak French, and those in the north speak Dutch. And Fleming is the Dutch-speaking part of Belgium, and the people there are called Flems, or they're Flemish. And so this was a bond that became very popular in Belgium, again around 200, 300 years ago with the Industrial Revolution. So with a Flemish bond, look at one of the courses in that wall that you see on the right. What's happening? Well, we can see a stretcher, and then we can see a header, and then we see a stretcher again, then we see a header. And so each course actually has the alternation of header and stretcher. It's not a case of we have a stretcher course and then on top of that we have a header course and on top of that another stretcher course. Each course has stretchers and headers incorporated into it. And so you can see that with the stretchers above actually deviate from the stretchers below, and the same with the headers. And so that creates quite a strong bond, because again you don't have any vertical joints. It is a little bit weaker than the English bond, but it is still quite strong. One of the disadvantages of the Flemish bond is, like the English bond, you have to make sure that the wall is at least one stretcher length thick, and the header bond too. And so the wall has to be of a certain thickness, and so that basically limits certain applications for this. A lot of villas wouldn't want to have an English bond, header bond, or Flemish bond because it makes the room smaller if the wall is thicker. And so that's why I think the stretcher bond these days is probably the most common. And yeah, it's at least one stretcher thick, but that's called a single Flemish bond, where the wall is one stretcher thick. But there is also another kind of Flemish bond called a double Flemish bond. Now, with a double Flemish bond, basically the wall is 1.5 stretchers thick, because basically those stretchers, even in the depth of the wall, will overlap. So that's called a Flemish bond. Final thing, one of the big advantages a Flemish bond will have over an English bond is you can actually use bats. You can actually break rocks and break the bricks, the blocks, and have them on the end. And so labour is a lot easier than with the English bond. So I don't know if you can see this. This is not a very good picture here, but you can see a double Flemish bond here. This is basically, you can see the wall is 1.5 stretcher lengths thick. So the top picture there is a single Flemish bond, and the bottom one is called a double Flemish bond. And you can see how the header and the stretcher actually overlap inside the wall. By the way, guys, I really think it would be, normally when I teach this, I'm actually doing this in class with Lego, and it's I have to say this is one part of the module of building materials and testing which is rather difficult to teach online. keeping that in mind, I'm going to be very lenient when marking you. If I do ask you questions about the different bonds, I don't expect you to have that great a knowledge of them. This goes beyond what is necessary in a way. Double Flemish bonds. And so, yeah, with a single Flemish bond, basically you have the two headers, the two working lengths of a header overlap with the working length of a stretcher. And that's why you always have those dimensions of a working length being, let's say, 225 millimeters for the stretcher length and 112.5 millimeters working length for the header length. It's perfectly 1/2 once you allow for the masonry to go in between them. And so you can get all of the blocks arranged in such a way. You can do English bonds, Flemish bonds, and they can be arranged in such a pattern. Now, you can also see there in the picture the bats. These bats are actually broken bits of block, and these are used at the end to make sure that the wall aligns, and it can be done quite easily. And so with a single Flemish bond, or cross bond is another term it's used, you've got a lot of the advantages of an English bond, namely that it's quite strong, not quite as strong as the English bond, but it's also a lot easier to make. So I have to say Flemish bonds are a lot more common than English bonds these days. So this is just a small comparison here of English bonds to Flemish bonds. So remember, the English bond is where you have courses which alternate between stretcher courses and header courses, whereas the Flemish bond has stretchers alongside headers in each course. Now, the English bond is a lot stronger because basically, it has no vertical joints, whereas the Flemish one, it's more vertical, I would say, the joints between following the masonry lines. But the great advantage the Flemish bond would have over the English bond is that you can use bats on the end of the wall, and so that means it's a lot faster to build, and it's less expensive. So those are the two more advanced bonds: English bonds, Flemish bonds. That said, here in Kurdistan, I have to say I've only ever seen stretcher bonds. When I go down to the Citadel and the bazaar, it's all stretcher bond there. The one example, though, is actually in certain parts of the Citadel with their clay oven brick masonry. I have seen in certain places they've actually used header bonds where you can see the header of the blocks, and that's actually the stronger part of the Citadel because of that. So let's talk about different kinds of bricks. Well, remember we talked about frogs before, and frogs are effectively ways where we can reduce the volume, reduce the mass of a brick for a given surface area of the face, so it's easier to use. So let's say a man can make a masonry wall without machinery to lift the bricks and things, so long as each brick doesn't weigh more than 5 kilos. Well, that will mean if it's a standard brick without any frog or without any hollows, then it's probably going to have a fairly small face, which means you're going to need more bricks in order to fill in the wall cavity. Whereas if you have a frog, or if you have a hollowed out brick, you can actually have a larger brick for a given mass. And so with that, you can actually reduce the labour, and by that the cost of the wall. So you can see that frogs were quite popular for quite some time, but these days increasingly cord bricks are actually becoming very common. This is where you actually have a frog or a cavity that goes all the way through the block. So there's actually a hollow section. And this is often arranged in rows, as you see there, or it could be small cylindrical holes drilled through. There is another advantage with this, which I will get to later. It's got something to do with reinforcement. Think about that. So when you stick the bricks together, this is just a very basic example, but there's a few different joins. So one is where you have a flush join. That's the one in the middle there. So that's basically where you're making the mortar flush with the face of the brick or the block. A V is where you cut it into a small V section. Concave is where you sort of run a teaspoon, and so you have sort of a circular hollowed out section. But you've got to remember, guys, that the mortar has less durability than the block itself. And so over time, the mortar is going to wear away. And so you're going to end up with little gaps forming between the blocks in time, and they need to be refilled with new mortar. So this is actually happening down in the Bazaar and the Citadel. So the Bazaar as well as the Citadel is actually a UNICEF heritage site, a UN heritage site. It's one of the oldest continuously inhabited places in the world, and you want to preserve that heritage. Now, unfortunately, Kurdistan doesn't seem to have enough money to actually maintain and to upgrade a lot of its heritage buildings. You can see that there's a big project going on in the Citadel. It's been going on since 2014, I think. One of the key things they're doing is they're replacing the mortar between the bricks in all of the buildings on the Citadel. If they don't do that, eventually the bricks will fall out and the building will crumble. The Citadel will crumble. They don't want that. So one of the key jobs they're doing is replacing the mortar between the bricks. Now, down in the Bazaar area below the Citadel, you can see there hasn't actually been that much investment. So you're getting a lot of buildings which were made out of clay oven masonry bricks. They're falling down now, and that's because the mortar holding them in place is wearing away. It's weathering away, and so the building is eroding. So with old buildings, when you do inspections, one of the key things you would do is check to make sure you don't have gaps forming in between the blocks if the mortar is not wearing away. And so using you would using a depth meter, you would actually probe to see how deep the mortar is, and ideally you don't want it any deeper than about 5 millimeters. If it's more than that, then you really need to inject more mortar between the blocks. So that's the type of joint or join. So that's how the bricks or the blocks are stuck together. Well, guys, I think that's enough for today. Masonry is fairly simple. We're going to I'm hoping that you feel like you've had a good introduction to masonry and you understand what masonry is, and you also have had a little bit of an introduction to a lot of the terminology. It can be a little bit daunting learning new vocabulary, but there aren't really that many terms. I think I've used maybe 10 terms, which are a little bit strange to you. But anyway, if you want to read more about Masonry, go to pages 223 to 239. That's in the Shan Somayaji textbook. That's not homework. Ignore that sign saying homework. It's supplementary reading. We're going to talk a little bit more about Masonry in the next lecture, in the first lecture of week 7. So thank you everyone, and goodbye.